Originally, I was going to talk about finding the hidden state machines in your applications, and I'm still planning on doing that talk at some point. I'll re-sign up to do that when it's actually more a talk and available to be presented. It has a lot of work left to it to get anywhere useful. So instead, I thought I'd still do something about state machines, and I just had been thinking about what would happen if you tried to build an application where the entire thing was basically just run by a set of state machines and the transitions within them. And what would that look like? It's kind of a thought experiment that I ended up codifying just to see what it would be like, and it's a little bit different. And I didn't really make any slides to cover this. I thought it would be more valuable just to kind of walk through some of the code that backs the application and how it works and why it does what it does, and was this a good idea? Was it a bad idea? Does it make any sense? I decided for the application, partly because a lot of people get their start on Rails by using the railstutorial.org, and they build kind of a little Twitter clone. So I whipped together a little Twitter clone using this methodology. So when you bring it up, you can create a new user or sign in as a returning user. But before we get too far into using the application, wanted to jump into actually some of the code here. So a little bit of thought process behind what I ended up choosing, how I ended up building it out. So I had certain features that I wanted in this application, and in my thinking it should be possible to define all of these features as a transition state of some sort. And so that's what I did. So I defined out all my state machines first, and then once the state machines were defined out, I did some business logic around them and then wired them up to controllers. So the views look just like you would expect the views to kind of look like, and the controllers look kind of like controllers, but each controller is basically using a state machine to do something. So I'm going to start where I started, which was some of the state machines. So the first thing I said is I'm going to want some users. So you have to have users in order to have the site do anything. So I created a state machine called user creation. And the user creation state machine, I said this is not on a particular object necessarily that has a particular state. It's more the application has a state. The application has a state where a user was not created, and it's moving to a state where they are created. And so that can be represented as a transition from uncreated to created. And I put a little, I'm using a gem called endstate, which I talked about a couple sessions ago, that allows you to define out state machines. And so I put an action verb on there called create, so I can tell the machine to create, and it will do this transition from uncreated to created. And it will only make that transition if that transition is given a parameter set with email, password, a handle, and a session object. And it has some guards in place. So we say, in order to create the user, it has to be a unique user in the system. And that's the only guard, that's the only rule. They have to be unique. And if they are unique, we'll go ahead and make their account. And so we'll finish the transition by actually creating the user and then sending them a validation email and then creating their session so that they can start using the application. So I kind of mapped out the business process of the creation of the user in preventing the user from being created if they chose bad things, or if they did choose okay, then what do you actually do to actually create a user? What are the steps, basically? And each one of those are represented by each one of these classes. And so the first thing I did is I didn't even bother with what happens in those classes. It was more like, okay, so these are the rules of how you create a user, and this is what needs to happen. So that's good enough for now. And I started mapping out all of these machines. So the next thing I realized is I have this thing where I'm sending out a validation email, so I probably need a way to actually act on them clicking the link in the validation email. So I created another machine called user validation, which transitions from, actually no, that one is validation, is it? Okay. No, it was the other one, sorry. I've got a couple, one that works on the application and the one that works on the user. So this one works on the application, where we're going from unvalidated to validated, and it requires oh, now I see why I'm confused. Sorry about that. This is what happens after you click the email, which is what I said we were talking about. So yeah, so I was thinking this was actually driving the email out. So this is when they come in and click that link, then it moves from unvalidated to validated, and it requires there to be a validation token and a session. And again, there's a guard here that says that there has to be a user in the system that actually is tied to that token. So if there wasn't, then we're going to bail out. There was an invalid token. But if there was, then we'll go ahead and validate that user and create a session for them. And you'll notice that I'm able to reuse this create session thing. So that's kind of cool that I'm already finding a little reuse in the system there. So each one of these I kept building out. I'm not going to go over every single one until we want to, at the end, maybe go back and dive into any specifics here. I do want to point out, though, that every single machine in the system is one of these application level machines that's going from one state of the application to another, except for the validation one, which actually acts on the user, and it's used in the validation process. So there's this concluder here that says validate user. I'll show you that in just a moment. What it does is it actually creates a state machine, a validation state machine around the user, and transitions the user from unvalidated to validated. So we actually do have a more traditional state machine that works on an object, the user object, to take them from unvalidated to validated. And I'll show you what that one looks like here. So this is the concluder for validate user. So in that chain of things that happens after we successfully transition the system to validated, then we basically take this validation service here, which is just a state machine, which is this state machine over here, and we call validate on it, which is going to return true or false. And that's what's going to come right back out of the concluder. If it's false, it can cause the whole initial validation system to roll back and undo itself. So there's no reason why it would. It's just updating the user record, but the database could fail or not be there or something like that. And that's the entire one there. So now that I've talked about some of the state machines, I wanted to kind of dive in and show off what some of the controllers look like. Starting again with the users. So we create a user with you'll notice that the index action and the new action look fairly straightforward. Index, we're just showing all of the users. The new action, we're just creating a new empty user so that it can back the form that's on the page. And the create action is where things start looking a little bit different. So in the create action, the first thing we do is create one of these user creation state machines. And a state machine, when using the in-state gem that I built, it needs to wrap an object. That's how it works. The object, by contract, has to support has to have a writable and readable attribute called state, unless you tell the state machine in the definition to use a different name. But by default, it's going to use state. So any object that has a state attribute on it that's writable and readable is fair to wrap with one of these machines. So I decided to make a thing called logical state that is in my models, and all it is a struct. And so it's a struct that has a state field on it, and that's all you need for the in-state gem to be happy, because it can actually change that state from one state to another. So So I do this, I create this state machine user creation and wrap the logical state with it. And then if I was able to create with a set of parameters, and these are my required parameters that I have to send in, then it will redirect to the root path and say welcome, and otherwise it will re-render the form. And I guess I didn't put an error on that one, but that's okay. And then I want to jump into, now that you see kind of how the controllers look, which is a little bit different than you're probably used to, but it's not too different. Normally you might new up an object and say if save, then do this, otherwise do something else. But what this allows us to do is separate out any logic around whether something's allowed to be saved or even created or anything else from the controller and put it somewhere else, like a service class, but specialized to this idea of state machines. I want to dive in a little bit deeper to the user creation, how that even works. So there's this guard that says require unique user. So require unique user, what it's checking for is do we have a unique email and a unique handle? Because you can't pick the same email and handle as someone else in the system. And then what that's doing here is basically saying, look up and see if there's a user in the system, and by email, and look it up by handle. And then it's just checking was there a duplicate user or not. And if there was a duplicate user, then nil will be false, and we'll fall out of this guard with a false, which will stop the whole thing from happening. And what we have here is a little failed operation, so that if we did fail like that, then it's going to stick our duplicate reason on the failure messages, which is just the problem, and that'll show up in a little flash message. If there was no duplicate user, then nil will be true, our guard will pass, and we'll go on to actually the next steps. So the next step is to actually create the user. And we see the first thing we do is we set a new key in our parameters. So we were passed in these parameters. You saw way back in the controller level. We're adding a new key called user to that, and we're sticking user into it. And then we're trying to save the user. Again, save returns true or false. If it fails, then it will roll back the whole operation. If it succeeds, though, it'll move forward. And we put a little rollback on here, so further down the line, if things fail and we roll back, we'll destroy our user and take care of that. Down here, this is assigning our user here basically creates a new user using the parameters that we wanted out of the parameters that we were given. And that's it. We just create this new user, new up a new user, and then call save on it. So there's nothing too fancy here, and this is pretty straightforward as far as what it's doing. And that's all it has to do is worry about creating the actual user in there. So then the next thing we do, assuming that that does pass and save into the database, is we want to validate the user. We want to send them an email. So we just use a mailer, which is just a standard mailer, and we tell it to deliver the validation email. And we don't have to have any logic in here. We don't have to do anything special, because at this point, we know there has to be a user. We're using the user that we stuck in to the parameters on the previous area. We don't have to check for that. We don't have to check if anything's true or false. All we have to do is just deliver the mail. We know that we can at this point, and we can move forward. Next thing and final thing that we do is create the session. So one of the things we required in the parameters was the session object. And so now what we're doing is just setting the user ID in the session object. And it's, again, very straightforward. I don't have to worry about what's there or not there. I'm just going to grab the user ID and stick it in the session. And this is a small class that easily is verifiable, that all it does is modify the session with this variable. And I point that out because while I didn't actually have time to generate a whole bunch of nice tests behind all of this, I just wanted to hack this out as a thought experiment. Each one of these is doing a very small thing that's easily testable. It doesn't do anything more than what it's asked to do, and you can test it in isolation from anything else in the system, and you don't have to worry about anything else, and let the machine itself guide the fact that it's able to do what it has to do in the right order. And each one of these machines is set up in basically the same way. I want to take a look at another one real quick. You can follow users as well. So this is very similar. We basically are taking the system from a not following to a following state, and we require a follower ID and a user ID, and we just make sure that the follower is not the user in question. You can't follow yourself. We require that the follower is actually there. We require that the user is actually there, and then we actually follow the user. And again, because all of those things have to be true, I'm just going to show you the follow the user one. This one is pretty straightforward because we just are basically creating a new relationship that is built up from the user and the follower, which have to be there at this point. They're guaranteed, and then once we new up this relationship, we just save, and it either successfully saves or it doesn't save. And we know we're in a good state at that point and have a user following another user. So I want to show you a little bit about how this actually works then. So if I'm a new user, I can sign up, and I get my little validation email. So the validation email part works, and I click validate, and it thanks me for validating, and I'm now into the system. So I'm logged in and validated, and that was all driven by the two machines that I showed you, the creation of the user and the validation machine. And then the validation machine used the validate machine on the user itself. And once I'm in, I can do cool things like post myself. And now I can shout yo at people, and it works pretty nicely. Except there's only one user in the system, me. So I'll go ahead and sign out and make a new user. And now I'm signed in as another user. Now there's two users on the list. I can follow Alex. And if I follow Alex and go back to the front page, I can see there's a tweet by Alex because now I'm following him, so I get to see his tweets. And can make my own back at him. And so you see it acts and works just like a standard application, but the entire thing is driven this way. Post creation is somewhat interesting. I wanted to show you that a little bit. The post controller under the create uses two machines. What it does is it figures out that a post is either going to be a brand new post or it's going to be a reply to someone else. A reply being defined as it starts with an @ handle. That's how we're defining it. Whether it actually was a reply or not, that's the definition of one. There's no actual reply function in the front end UI yet, but you could fake one out by doing an @ handle. And so what we do is we try to create a standard post, but that might fail. So we then try, if that fails with an OR here, to create a reply post. And so we basically have one machine a post-creation machine that has a couple of transitions on it. One can transition to a created post, and one can transition to a created reply. And we'll take a look at that real quick. So it's done in the same mechanism as the other ones that I showed you, but there's two options here. I can either go from uncreated to post-created or uncreated to reply created. I don't know which one it is, nor do I care, but I know that they're both possible. So I'm just going to try and do one transition, and if that fails, I'm going to do the other transition, and that might fail as well, but I've exhausted the different options that I have. And so the differences here are if it was just a straight regular post, then we're going to require that the user exists, and we're going to require that it's a post message, so it's not one of these replies, and then we're going to create the post. In the reply area, we're going to do very similar things. We're going to require that there's a user, only this time we're going to require that there's a reply message instead of a post message. And if that's true, it'll create the post, but then finally it'll notify the original poster, hey, there was a reply to your tweet. So while I just said yo back here, if I had actually said at Alex, yo, let's capitalize that, be formal. A email pops up. This is an email that the system sent out to Alex saying that someone replied to you, and it puts their little message in there so that I can see that. And it also just posts the message as usual. So it was able to see that it wasn't a regular message, but it was one of these reply messages, just by letting the guards actually handle the checking of that. So require post message actually just uses the other guard that is require reply message, and it checks that it's not allowed and then on the require reply message, since that's the one that's special, that has the actual logic here, where we basically are verifying that we have a handle that matches a user in the system, and not just some regular app thing. So we can test that out. So if I just say at somebody, no email popped up, no email was created, it still gave me the post. It saw it as a regular post because there's no user in the system with the handle somebody. And so that handled that logic right there. And that's about it as far as what I wanted to show off on how the application works. And I imagine there might be some questions, or not, but I'll open it up if there are any more comments. Does anyone think it was a worthwhile thought experiment? Did it make any sense? Yes?
Yes, it's interesting. Now, let's suppose that this was actually even more complicated application than this. And I had never seen your app, but all of a sudden I needed to work on it and add a feature or something. Because of the way that all of the functionality is broken into all of these pieces, is it going to be easy for me to get a good picture of like what's going on?
Yeah, so what I like to do...
How would I do that when I...
And what I've found, to answer that, I actually find in some ways, yes, it is actually easy, and it's easier than in some apps. Because if you understand, maybe you don't understand what I was doing with this app, but if you look at it and see that it's got all these state machines that are getting called, and you start looking at these state machines, if you look at every one of these state machines, and it's clear that each one is a thing that happens in the application, it's actually fairly easy to understand, at least in my mind, that this is how a user is created. These are the steps. This is what has to be true, and then if it is true, this is what happens after it's true. And you can actually see that. Well, I'm on the post one, but you can actually suss out all of the rules of the application just by looking at these machines. And if you want to say add a new feature, if your new feature is a completely brand new feature, you could start by just creating a new machine. If your feature is someone now requires that in order to post, you have to have something true about you. I don't know, maybe you can't post unless you've been validated. We have that validation email at the front, but we don't ever check, are they validated? So someone puts a new rule in that you're not actually allowed to post unless you're validated. So you come to the post creation here and you say, okay, well I need to make sure that they're validated, right? So I'll just add in a new guard. Guard require validated user, something like that. And then I go create this guard that just checks to make sure that the user, I required a user, so I know I have one at this point. So all I'll have to do for this guard is say, make sure that the validated flag on the user is true. And if so, then it can move on and finish the rest of the post creation, and I can put that down here as well. And we could actually probably even build that out quickly here by saying under guards, do a new guard, require validated user.rb, and I'm just gonna copy that one. For this one, I don't need a repository here. I'm going to define user as params user because I know there has to be a user in the params. And you must validate. And we're just going to check user.validated. And now we've added in validation requirement for posting. And if I go back here and I log out, and I make a new user, and instead of clicking validate there, I go back here, I'm signed in because they successfully created me, but I'm not validated yet, and I try to yo. I didn't, yeah. I need to require validated user. Whoops. What is my user called? Validation. Actually, I can wrap that and do this. Validation, new user, validated. There we go. That's what I want. I'll actually go back here and try and post again. You must validate. So that got added in there pretty straightforward on the fly. Yeah.
It seems strange to me that your states do not correspond to anything that's persisted anywhere.
Right, they're not persisted states. They're.
Is that normal?
Well, that's not normal, which is why this was a thought experiment. And what would happen if it was not persisted states per se? And I could argue that they're somewhat persisted because most of them involve either changing something about the system, creating an object. So a particular state on an object isn't necessarily persisted, but the fact that the database did not have a user and then now has a user, you have done a persistence operation. You've persisted a new a user into the system, so the system itself is now in a state of having one more user.
This is like even a more general application of state machines, using them to model just the flow of a program.
Yeah. Right.
That was
the general idea: is can we model all of the business logic and program flow as represented as transitioning states, and using the fact that this gem allows you to do these fancy guards and concluders for business logic.
Yeah, it grew out of the idea that if you use end state in effect properly, what you end up with are a bunch of very small classes that only do one thing, whose job is to handle the from step to step to step of the transition. And so if you expand on that idea outside of the narrowness of this object in the database that I want to have a life cycle, the actual flow of a user's interaction with your application could be described as a life cycle. And so what would that look like?
So there we go.